Today's lesson is going to be on trapezoids and kites. Okay, so it's mainly definitions and understanding what the different sides and angles mean if you have a trapezoid or a kite. Okay, a trapezoid is a quadrilateral with exactly one pair of parallel sides. It also has supplementary same-side interior angles. Okay, so both these two shapes on the screen are trapezoids. You can tell they're labeled TRAP. It says a trapezoid has one pair of parallel sides. So for this trapezoid, those two sides are parallel. The arrows mean they're parallel. Okay. It also has supplementary same-side interior angles. So if you remember, whenever you have parallel sides, same-side interior angles are angles that are on the same side of a transversal, like this one and this one. Okay. And they're inside the two parallel lines. Okay. So if those two same-side interior angles are supplementary, what that means would be measure of angle T plus the measure of angle P has to be 180 degrees. Okay, same thing on the other side. These two angles, angle R and angle A, are also same side interior angles, so those two angles together have to add up to 180 degrees. Measure of angle R plus measure of angle A equals 180. Okay. Isosceles trapezoid is a special kind of trapezoid. Okay, think about the word isosceles. We used the isosceles with triangles before. What that meant was that two sides were congruent on a triangle. It means the same thing for trapezoids. It just means that those two legs have to be congruent. Okay, so the isosceles trapezoid is still a trapezoid, and that opposite sides are parallel. However, in addition to having same side interior angles supplementary, those two legs have to be congruent. Okay, so that's what makes it isosceles. If the two legs are congruent, it's isosceles. It just so happens that with any isosceles trapezoid, the diagonals are congruent. So you see IP, this one, is congruent to ST, this one. Okay, so IP congruent to ST. Okay, these two properties, where the legs are congruent, the diagonals are congruent, are only true if it's an isosceles trapezoid, not for all trapezoids. Okay, then the last important part about trapezoids is the midsegment. The midsegment, or median, is a segment that goes through the middle of the trapezoid. So if you see XY would be the midsegment in this picture. The length of XY is actually the average of the two bases, AB and DC. Okay, so there's a formula for that we're going to need to know. The length of XY equals the average of the two bases. So AB plus DC divided by 2. Okay, so if we add up this length plus this length divided by 2, we're going to get XY. So say I know some of these lengths. Say AB is 10, XY is what I'm trying to find. Say DC is 16. Okay, if I want to find XY, I'd add up the 10 plus the 16 and then divide that by 2. Okay, 10 plus 16, that's 26 divided by 2. 26 divided by 2 is 13. So that tells me that XY would have to be 13. Okay, and then go ahead, slide down. The last definition for today is for a kite. A kite is also a quadrilateral, but it's a little different. It's got two pairs of congruent consecutive sides. Remember, consecutive means next to each other. Okay, so the sides that are next to each other are congruent, as in KE and KI are congruent, and then also ET and IT are congruent. Okay, it also has perpendicular diagonals. So that means when you draw on the diagonals, like on the second shape over here, the diagonals are perpendicular. They meet at exactly perfect 90-degree right angle. Okay, and then the last part of this definition, it also has exactly one pair of congruent opposite angles. Okay, the congruent opposite angles are in between the non-congruent sides. Okay, so angle E is congruent to angle I. However, there's only one congruent pair of opposite angles. The other ones, angle K, is not congruent to angle T. Okay, only one pair of congruent angles. Okay, tomorrow we'll do more practice with the different measurements on kites and on trapezoids.